Just like a username and password controls the ability of a person or entity to access a particular system, a blockchain wallet controls the ability of a person or entity to access a blockchain. Reading data stored on a blockchain does not require any authentication or a wallet, but if you want to edit data or execute code on top of a blockchain system, you will need a wallet. Like typical username password authentication mechanisms, you have the concept of a username or ID for each account on the system, and a password which can be used by each account holder to prove that they are the person that originally created the account, assuming that they never share or compromise their passwords, of course. A blockchain wallet works just like a username and password and is comprised of two parts: a public key and a private key. The public key acts like a username and is a sequence of characters that identifies each account that uses a particular blockchain. I keep saying particular because there are many blockchains. The private key acts as the password for the account represented by the public key. A private key is a sequence of characters just like the public key, but you'll often see the private key transformed by various algorithms into a sequence of words called a seed phrase. Seed phrases allow humans to more easily remember their private keys. Because humans are prone to picking usernames tied to personal profiles and passwords that can be easily guessed, the Web3 approach to account creation generates both usernames and passwords on each user's behalf. Web3 usernames and passwords, aka public and private keys, are not determined by user input, but instead are auto-generated for each user via military-grade cryptography. Because Web3 account creation relies solely on the math underpinning these cryptographic algorithms and not on any internet-connected systems, account creation can actually be done offline and does not rely on any third parties. This is fantastic for protecting private keys, as private keys never need to be connected to the internet for users to use a blockchain. When a user wants to use a blockchain, however, they must provide a digital signature derived from their private key that will be used to prove to the operators of a blockchain that the data associated with a public key has been approved to be changed in a particular way. The digital signature algorithm used by most blockchains is called ECDSA. Once again, your private key does not and should never leave your computer or be shared with anyone except yourself. So as we were saying, if someone wants to read the data on a blockchain, they do not need to be authenticated or have a wallet. But if they want to edit data on a blockchain or have a blockchain execute code on their behalf, they will need a wallet in order to supply two things. One, a digital signature derived from the private key of their wallet to prove to the system that an action that affects their account has been approved. And two, a small amount of cryptocurrency that depends on the blockchain being used. The small amount of cryptocurrency alluded to in point 2 is paid by users to the operators of a blockchain and is how the operators of the computers running a blockchain system are financially compensated for their service.